Okay, this is going to be problem 2.8 for the Mastering Physics homework. So, problem 2.8 is asking, at what time is x equivalent to 20? Based off of this velocity over time graph. And so, what we know, or what's given to us, is that the starting point of t0 is equivalent to 0 meters, which is the starting position. So, going from the starting position and all the way up to this point here, because this graph is different from this graph. So what we want to find out is, what is the acceleration of this first little graph here, the line 1 that I labeled. And so that is found from the change in velocity over the change in time, which is positive 10, so it goes from 0 to 10 velocity over 4 seconds, which is 10 over 4. And that means the acceleration is 2.5. And so, doing the OFART process, we find that the initial velocity is 0 there. The final velocity is 10 meters up here. The acceleration is 2.5, which we found from here. The starting position, as we know, is going to be 0, shown here. And then the final position is going to be 20, because that is what we want to find. And so that leaves the time unknown. So basically, what we do is substitute this equation with all of these values. So then we're left with 20, which is the final position, is equivalent to 1/2 times 2.5 t squared plus 0 plus 0t plus 0. And I cross those out because they are zeros and can't really have a value from them, so they don't really matter. And so, solving this, we find that 20 is equal to 1.25 t squared, divide that by 1.25, and then square them, so then 4 is equivalent to t, which basically means that at 4 seconds, x is equal to 20 meters, meaning it's at 20 meters. So that's one of our answers for this problem. Now we're left with the second line, which we're trying to find at which point on this line is the position going to be 20 again. And so we know that at the top of the line it's going to be 20 meters. And we also know that this whole line right here, from 4 to 8 seconds, that is going to be a positive velocity, meaning it's going up. The position is going to be increasing. And increasing from 20 is never going to equal 20 again. It's just going to all be greater than 20. No, it'll just be greater than 20. So that means the only possible answers would be in this bottom section down here, which is 8 to 12 seconds. So what I'm going to want to do is find the position that is at 8 seconds, which can be done by finding the acceleration of this line, which is from 10 meters to 0, that's negative 10, which is the delta v over the delta t, which is from 4 to 8 seconds, which is also 4 seconds. So that means the acceleration for the second line is going to be negative 2.5. And so that acceleration is the acceleration. Okay, so then doing the OFART again, we find that the initial velocity is going to be 10 meters per second. The ending velocity, or the final velocity, is going to be 0 meters per second. The acceleration is negative 2.5 meters per second squared. The initial position is going to be 20 meters. Our final position is going to be unknown, because that's what we're trying to find. And the time is going to be 4 seconds, because that's the distance between these 2 points. And so, plugging that into the equation again, we get our unknown, which is x, is equivalent to 1/2 -2.5 4 squared plus 10 times 4 plus 20 meters. And so, solving this, we get -1.25 times 16 plus 40 plus 20, which is 60 plus 60. 16 times 1.25 is going to be -20, which is equivalent to x, meaning x is going to equal 40 when t is 4 seconds after this point, meaning x is equal to 40 at t equals 8, because it starts from here to here. That's 4 seconds, plus another 4 seconds would be 8 seconds. And so we know at this point x is equal to 40. And now what we need to find is at what point is x equal to 20 again from down here. So what we'll do is find the math of it. So the acceleration is the exact same again, going from 0 to -10, which is -10 over 4 seconds, which is again -2.5. And then doing OFART again, we know that initial velocity is equal to 0 meters per second. The final velocity is equal to -10 meters per second. A is equal to -2.5. Initial position is equal to 40. The final position we're going to want to be 20. And the time is what the unknown part is. And so, plugging all these values in, we find that 20 is equal to 1/2 of -2.5 t squared plus 0t plus 40. And then solving this, 0t is nothing, then we subtract 40 from both sides. That's -20 is equivalent to -1.25 t squared. Divide that by -1.25, we get 16 equals t squared. That's an easy square to solve. It's just 4 would be equal to t then. And so 4 is again equal to t, but this is only after 8 seconds, which is here, meaning that after 4 seconds from this point, x is going to equal to 20, meaning x, or time, is equal to 12 again, or 12. To get to 20, it takes 12 seconds and 4 seconds. So that is going to be our answer. So 12 and 4 equals t. And so that's the answer, but also there's a much easier way to solve this than like going through all this math, and that would be looking at these 3 different sections of the graph that I could like label. So there's that part, and that part. Basically, each of those parts has the exact same acceleration, meaning that, and they also go from their initial velocity and final velocities are all interchangeable, meaning they're all basically the same. Because also the delta, or actually no, so they go from 0 to 10, 10 to 0, and 0 to -10. And those are all pretty much the exact same values. And since they're all the same values, you could say that the change in position from between each of these graphs is the exact same. So from here, it's a positive 20. Here is another positive 20 because it's still in the positive position on the graph. Then here would be negative 20 because it's on the negative velocity side. So that would just be 20 plus 20 minus 20, which is negative. Nope, that's just 20 again. And that's the answer. 12 x is equal to 20 at 4 seconds and 12 seconds. So, yes.